Bismillahirrahmanirrahim. This is Sophia Suhaili is here. Assalamualaikum, my dear students. How are you? Hopefully you're doing well. So again the topic higher derivative. Okay, what are the higher derivative? If you are taking the derivative of any function more than one time, like its second and first derivative is called dy by dx. It's in this formation it is called the first derivative of x, and if you are taking its derivative d by dx of this dy by dx again, so d by dx of this function again, this will be noted as d square y by dx square, and this will become second derivative. Okay, this is called the higher derivative. And what we need to find out the higher derivative, I have explained in my previous video already that you must know how to find dy by dx. You must know to differentiate a variable properly. Differentiate a single function. Okay, differentiate a single function. That is the most important thing to do. Okay, so higher derivative I have explained in my previous videos also. So just take out the derivative of any given function for the first time, and then on the resulting derivative apply the derivative again on that one answer. Okay, so just take one more example. I have explained the previous cases in my previous videos also. I have taken the reference from the question of exercise 2.7 from the class 12. Equally it's useful for A levels also. Okay, if we have a function y is equals to log of 2x plus 3 over 3x plus 2. If we have any function of log, this is called natural log. Natural log and common log, the laws are same for both. Okay, whenever we get the question, whenever we get a function in the log form, so what we have to do, we can apply the logarithm laws to make our function in a simple form. Okay, so like if the function is given in the quotient form, our logarithm laws are saying that, as we know before, log of a mn, log to any base if applied on a number in the product form, so it will be equals to log am plus log of n to the same base. Okay, similarly if log a m by n, any function given the quotient form, we can apply log of m minus log of n with the same base. So we will use this one log to change this question log of 2x plus 3 over 3x plus 2. So first I will write it as natural log of the first function minus natural log of the second function. Okay, as in the linear form it's easy to take the derivative. Now we will differentiate with respect to the variable involved. Variable is this one. Okay, so d by dx of y, differentiate this with respect to x. I write the statement as it is. In the next step, I can write this as dy by dx, and this, the derivative of this is, as I have explained that before also, that derivative of natural log of the function is equals to 1 over that function and then derivative of that function again. So this you must keep that in the mind. Okay, so we will use this one relation to find out the log of the first function minus the derivative of the second function. Find out the derivative of the first minus derivative of the second function. So derivative of the first function, I will write like log of 2x plus 3 minus derivative of natural log of 3x plus 2. Fine. Now derivative of natural log is 1 over 2x plus 3 and derivative of 2x plus 3. Okay, minus derivative of this natural log means 1 over the same, this one, as 1 over this derivative of this function. Then same this one, 1 over this and derivative of this function using this formula. Hopefully you understand over here. Now derivative of this we have done many times. The coefficient is 2, it will be as it is. Derivative of x will be 1 plus derivative constant will be 0. And downside denominator is 2x plus 3 minus. Derivative of this 3 is coefficient will remain as it is. Derivative of x is 1 plus derivative constant is 0. Denominator is 3x plus 2. Okay, so this will become 2 over this and this will become minus 3 over this one. So let's write that on the next page. I will turn over the page. Be careful when you are turning the page, because most of the time we do a mistake. It's a human error that whenever we're turning out our page, we can have a mistake over there. So be conscious and be focused when you are turning your page. 2 over 2x plus 3 minus 3 over 3x plus 2. Yes. So this is our first derivative is done. I can write it in the exponential form because it's easy to do the expansion like this one also. 2x plus 3 inverse minus 3x plus 2 inverse. Whenever we are taking something or any term from the denominator to numerator, its exponent will become negative or exponent will change its sign. Whenever we are shifting some term from numerator to denominator or denominator to numerator, we can shift, but the exponential sign will be changed. Okay, so I'm shifting this term from here to the numerator, so exponential sign will be changed. Now the first derivative is ready. Let me highlight this one, put the star over here. Now we will find out a second derivative. Derivative of the y1 and derivative of the complete expression I will write once as it is. Plus 2, fine. Okay. Then when I am writing the derivative of this, I will write the coefficients in the start and the derivative of the function I will write. Minus 3 derivative of 3x plus 2 minus 1. Okay, I write the derivative of the first term minus derivative of the second term. The question is that why I shift them from here to up. Okay, because upper one is only the constant number. Okay, if I am just taking the derivative as it is, I have to apply the quotient rule. And if I am taking it upward, I have to apply the power rule. Power rule is comparatively more easier than to apply quotient rule. We are applying the quotient rule if we have function in the numerator and function in the denominator. Then we are applying quotient rule. We have to apply the quotient rule. But if numerator is only a constant number, so better to shift the function in the numerator and then the derivative is done easily only by the power rule. Okay, here on this step, now I will apply the power rule on that. I told you that power will be written in the start or power will be multiplied in the start. Okay, so minus 1 is coming here with 2, which is the coefficient, and power minus 1 or power reduced by 1. Minus 1 because it's a negative number, so I will write in detail. If it's a positive number, I can write the next reduced number also over here easily. Okay, and now the derivative of this function, derivative of this function under the power 2x plus 3. Now the derivative of this is done till here. Okay, now minus 3 power in start 3x plus 2 power minus 1 or power decreased by 1 or power reduced by 1, and derivative of the function inside that power. Okay, so power rule I have applied till here. Now equals to, this has become derivative of the first function will become y2. It's the second derivative, y2. This is the single, this one step, y2. Yeah, from here now I will just simplify this over here. Minus 2, 2x plus 3 minus 2, and derivative of this coefficient stay as it is, derivative of x is 1 plus 0, minus plus 3, okay, minus change to plus 3 ones are 3, now 3x plus 2 minus 1 minus 2. When we are adding the integers, the integer will remain the same sign. Two negative integer give again a negative integer. Derivative of 3x. 3 is a constant number. Derivative of x is 1 plus 0. Okay. So this one is till here and this complete is simplified till here. Let me write the next line now. Okay. I want to change the color so that you are little clear about the steps. That this is the second step, means this is the second last step which I have just done. This is the new step. Okay, so minus 2 times 2x plus 3, exponent is minus 2 and this number become only 2, plus 3x plus 2, exponent become minus 2 and the number is 3. Is that okay? Now what happened that these two numbers can be multiplied together. Minus 2 2s are 4. So I can write minus 4 and the term. Here on this step, if we have to continue for the third derivative, then we can keep that as it is. Let me write that once, then I will explain what I want to say. 2x plus 3 whole power is minus 2 plus 3 3s are 9. 3x plus 2 whole power minus 2. This is the second derivative. Now the second derivative can stay as it is if you need to find out the third derivative. But if you need to find out and close till the second derivative, you can write the exponents in the positive exponent form also by changing them. Minus 4 from the numerator by shifting them from numerator to the denominator. Plus 3 square plus 9 over 3x plus 2 whole square. So here second derivative is completely solved and done. Yes, you can stop till here as well, but if you want to make single fraction, if you want to give the answer in the single fraction form, you can take the LCM also, or you can make the denominator same. So you can obtain a single fraction form. So this can be obtained like this. The common denominator, for the common denominator, LCM will include this term also, okay? Or you can multiply up and divide by the same factor, like this up and down. This multiply up and down, it's called cross multiplication. When this is multiplied, minus 4 times 3x plus 2 whole square plus 9 times this multiply up 2x plus 3 whole square. And downside the product of both, because they both are totally uncommon factors. 3x plus 2 whole square. If you are solving minus 4, it will just increase your algebraic calculation or algebraic simplification. A plus b whole square, the formula you can use over here, which is telling a square plus b square plus 2 times a and b, okay, plus 9, a square plus b square plus 2 times a and b. Denominator is same, 2x plus 3 square, 3x plus 2 square. The next line, minus 4. I'm writing the calculation little directly. 3x square means 9x square plus 2 square means 2 2s are 4 plus 2 3s are 6, 6 2s are 12x, okay, plus 9 2x square. 2 to the 4, x square plus 3 square means 9 plus 3 to the 6, 6 to the 12. X divided by, the denominator stays as it is, 2x plus 3 whole square and 3x plus 2 whole square. Okay, fine. Now open the terms, multiply these. All terms will be multiplied by minus 4 with the external coefficient. These all terms multiply by the 9. So minus, when the sign is minus outside, internal all signs will be changed. Okay, keep that point in the mind. Because why? As minus multiplied to plus will change to minus. Minus multiplied to minus will change to plus. So we can say simply that if the minus sign is multiplying outside, opening the bracket, all the internal signs, they have to change. 4 9s are 36, x square minus 4 4s are 16 minus 4 12s are 48, x plus 9 4s are 36, x square plus 9 9s are 81 plus 9 12s are 108, x divided by, the denominator stays as it is because we are not doing any calculation for the denominator, we are just keeping it as it is. Now this is extra working. If you want to skip this working, you can skip also because your derivative is done until here. If you want to change into one statement or one term, one connected term, so you can make that also. Otherwise, this is done. Minus 36 whole square, positive 36. They can cancel each other and the remaining you can solve. Like terms to the like terms. The term with x are like, constant and constant are like. Positive, negative, so I will subtract. 8 minus 8, 0. 10 minus 4, 6. Positive 60x. This is positive, so I will subtract from here. Take borrow. 11 minus 6, 5. Here left 7. 7 minus 1, 6. Sign of positive. Divided by the same. 2x plus 3 whole square. 3x plus 2 whole square. So this could be your possible answer. If you write in one term, if you write to represent the answer in a single term. Otherwise, stay here also. The second derivative is done. This all algebraic manipulation you are doing only just to solve these two fractions and taking only single fraction for the answer. So thank you so much. If you like my video, if you understand my teaching styles, so please subscribe to my channel.